we had finished with the mass spectrometry. हम लोगों ने NMR स्पेक्ट्रोमेट्री जो है वो सबसे पहले की थी और वो कंप्लीट अभी नहीं हुई थी उसके साथ में mass spectrometry जो है I've just connected it. So today we are going to start with the next part of NMR spectrometer. Okay, so let's start with the NMR spectrometer. So how do people can elucidate the structure of a organic molecule? Okay. First of all, my dear students, when I told you mass spectrometry will give you the empirical or molecular formula of the compound. Okay. So whenever you want to find out the structure of that organic compound, you have to use the NMR spectrometry. So for NMR spectrometry, my dear, you have to use a small test tube. Okay. In that test tube, first of all, you should take the sample whose structure you have to elucidate. Okay. So the sample, it could be solid form, it could be liquid form. Okay. It could be anything. Okay. Now to dissolve that sample, you should use a solvent. And the solvent we should use, that is the proton-free solvent. Proton-free solvent means that this solvent does not got any hydrogen inside it, normal hydrogen. Okay, so this proton-free solvent, there are two. The first one, that is CCl4, which is called as the tetrachloromethane. Okay, this one does not contain any hydrogen inside it, so that is why it's a proton-free solvent. The second one, the second solvent we should use, that is CdCl3. I think when you people have done the free radical substitution, you have done a thing which is CHCl3. Okay, so this is called as the chloroform. It is basically trichloromethane. This is also used as a chloroform. So, okay, so hydrogen is the normal isotope of it, which is the protium one. But if you replace this hydrogen with the deuterium, deuterium, you know that it got one proton number and two neutron number. So its neutron number, that is 2. And I told you NMR spectrometry could only be done for those elements which have odd number of neutrons. So this one is having even number of neutrons. So its NMR spectrometry cannot be carried out. So it does not got the hydrogen inside it. I mean, it does not have the NMR spectrometry. Why? Deuterium has the even number of the neutrons. Okay, so this is called as the deuterochloroform. So this deuterochloroform, that could also be used as a proton-free solvent because this one does not contain proton. Proton is basically the hydrogen which has a neutron number of 1. Okay. So these two things, you can use any one of them as a solvent. Okay. The third thing you should use up here, that is a reference material whose chemical shift is 0. Okay, so that substance, my dear, that is tetramethylsilane. So this is tetramethylsilane, or this one is also called as the TMS. TMS. Okay, and what is this tetramethylsilane? Let me draw its structure to you. So this is silicon. It is joined with the methyl group. This is joined with the methyl group. This one is joined with the methyl group. and this one is joined with the methyl group. Okay. Now, if I'm going to ask you people that how much peaks are possible for this compound. So, my dear, this one CH3, it does not have a label. You got the hydrogen, so it has got the singlet. Okay, this one is also singlet, this one is also singlet, this one is also singlet. And all the four hydrogens, they are present in the same environment. Okay, so they form a singlet. Okay, so now keep remember, my dear students, whenever NMR spectrometer is being used. Okay, so the first peak formed, that is of PMS, and where this peak is formed, from that place the zero that is being started. So this is PMS. So its chemical shift is zero. It does not have different environment. It got only one environment. Okay, a singlet is produced, even though there are present four places of hydrogen, but they are of same environment. Okay, so that is why wherever the peak of this TMS is produced, we write it as zero. Okay, why? Because its chemical shift is zero. It does not contain the neighboring hydrogen. Did you get it? सिगरेट के ऊपर फोर भी लिखेंगे यार, वो लिखने की, वो हमारे अपने लिखने के लिए होता है। इसका सिंगलेट बनेगा, जहां पे बनेगा वहां से जीरो स्टार्ट होगा, भी वो बनाते हैं। Did you get it, guys?
Yes.
Yes, sir.
Okay, now my dear students, what we are going to do, have a look up here. Again, I'm going to take this small test tube in which the three things are present. The first thing present, that is the sample. The second thing present, that is the proton-free solvent, that is CCl4. And the third thing present, that is TMS, tetramethylsilane, whose chemical shift is zero. So these three things, they are mixed in each other. Okay. Now, what should you do? You should take this test tube, put that test tube in a magnetic field. Okay. That magnetic field could be electromagnet or it could be permanent magnet, depending on you. Okay. If it is an electromagnet, then you can change the strength of the, normally the magnetic field used in that case, that is electromagnet, because we have to change the strength of the magnetic field. ठीक है जी, करंट ज्यादा करेंगे तो मैग्नेटिक फील्ड की स्ट्रेंथ ज्यादा हो जाएगी. करंट when it is less, the strength of the magnetic field would be less. Okay, so this is the magnetic field north and south pole, and here we got a radio wave oscillator. Okay, this is the radio wave oscillator. Here we got a radio wave detector, and here we got recorder. This is the recorder. Okay, now guys, everybody just listen. How this is a simplest form. This is not the real NMR spectrometer. This is the NMR spectrometer. It's a gray diagram just to make you understand about it. Okay, so now what would happen, guys? Radio waves, they are being passed from that sample like that, from here to here. Okay, so these radio waves, they passes through that test tube. Let's suppose if the radio wave oscillator sends 100 radio waves and detector receives the 100 radio waves, there is no signal. But if the radio waves oscillator send 100 radio waves and the detector detect only 80 radio waves, so it means the 20 radio waves, they are absorbed. Okay, they are absorbed up here. And I told you in the first lecture of the NMR, where they are absorbed, to jump the spin states from low energy to high energy level. Did you get it? Okay. So now when they are absorbed, the detector is going to detect it, and the recorder is going to record it in a graph. So here we got the abundance, and here we got the chemical shift. And chemical shift is denoted by this symbol like that. Okay, this is the symbol of the chemical shift. So the first peak formed, okay, that is of PMS, and from that place the zero start. Okay, so now whatever the sample we got, it formed triplet, quadruplet like that. Okay, in this way. Okay, so 0 to 12, that is for hydrogen NMR range. Okay, so these are the different peaks formed. Now, by using these peaks, we can find out the structure of the organic molecule. Did you get it, guys?
Yes, sir.
Yes.
Okay, my dear students. So let's discuss the structure of this one. Let me solve this question first of all for you. He has said a sample of a liquid P was found at the scene of the crime and was analyzed using mass spectrometry and NMR spectroscopy. The mass spectrum has M and M plus 1 peaks. So by using this one, you can find out the number of carbons. So first of all, we can find out the number of carbons. Number of carbons. Okay, that could be find out by M plus 1 times 100 divided by M into 1.1. The value of M plus 1, that is 0.22. Okay, times 100 divided by the value of M, that is 5.1 times 1.1. So if you solve it up, let me know what the answer you got. 3.9. 3.92. 3.92 means that is almost equal to 4. So you have to make it close to the whole numbers. Okay, whatever the whole number is closer. So it means 4 carbons are present in this compound P. Okay. Now the number of hydrogens you can see from here 3 and 3 6 and 2 8. So C4H8. Okay. Now he has given you the total M over E value. M over E value total means it's the MR. Okay. So let's check that how much, what is the MR of the carbon and hydrogen we calculated. So 12 into 4 for carbon and 1 into 8 for hydrogen. So what it would be? 48 plus 8, that would be 56. Yes. 88 minus 56, it would be 32. Yes. So 32 means we got the 2 oxygen up here. Okay. So it means that is the formula of the compound by mass spectrometry. Did you get it, guys? Who's that? 4 2 to 16. Studied one. Yeah.
Yes, sir.
Muskan, did you get it?
Yes.
Okay, now it means your molecular formula, that is C4H8O2, by using all the information up here. Now you have to find out the structural formula. If you look up here, this is the triplet. It got the 3 peaks. This is 1, 2, 3, and 4. This is the quadrat. And this one, that is the singlet. I told you, my dear students, whenever triplet and quadruplet, they are present in a compound, it means CH3 is joined with the CH2. Okay? Okay, now here we got the singlet. So it means neighborhood is destroyed. Neighborhood could be destroyed by C double bond O, okay, or by putting O. So I'm going to write this one in the form of 2O. Okay, and then we got 2 oxygen up here. So put the second oxygen up here, and here you can put like that C double bond O. And then you got in the singlet you got 3 hydrogens. So 3 hydrogen means it would be CH3. It would be CH3. So either this one or either this one, that would be your structural formula. Okay, did you get it? Yes. Now we find out that structural formula using the data booklet. In the data booklet, you are being given the different values. Uh, Let me see if I got the data booklet with me. Uh, if you people open up the data booklet, we can see these values up here. Okay, these values are present up here. This is 1.1, this is 2, and this is I think 4. Okay, so you see the values from the proton NMR, where the values are written, and you can see the groups present up there, but that would make you the task difficult. I would suggest you, by looking at the triplets and quadrets, make your own triplet and quadrat are present. So it means CH3 is joined with the CH2. Make it by yourself. Otherwise, data booklet से निकाल के वहां से भी निकलता है, but that will create you a lot of problem. So let me find out data booklet charts. I'm going to share a screen with you now. We will do the same question by using this one now. Okay, so if you look, this is the thing which is being given. Okay, so this is called as the hydrogen NMR. If you look up here, this is the hydrogen NMR chemical shift values. Okay, so these things are values are given up here. Okay, so the first value was given at 0.9 to or 1 equal to 1. So 0.9 to 1.7 we got CH3, so we should write CH3. Okay, and then the second peak was present at 2. I told you. तो 2 के ऊपर देखें जी क्या पीक्स आ रही हैं. एक तो ये वाली आ रही है, आपको ये वाली पकड़ लो. CH2 के साथ C double bond O present है, because you got the triplet and quartet, so that is why you should pick these two. Okay, and then the next peak that was almost present at number 4. तो 4 के ऊपर जो है वो चेक कर लेंगे कि आपका जो है वो क्या प्रेजेंट है. So if you look up here, 4 के ऊपर आपका ये O और CH3 है, तो O and CH3, so this is also present up here. So you can make the structure by using this data booklet as well. Did you get it, guys?
Yes.
Okay, guys, now have a look at this question. Okay, first of all, calculate the number of carbons. Okay, M and M plus 1. Use these values to find out the number of carbons by your own. Come on, 0.03. Okay, guys, so it means you people got 3 carbons in this one. So see this formula, carbon X value is 3, so C3H6O. So it means that is the formula. So we should keep in mind that we got 3 carbons. Okay, now if you look up here, okay, if you look up here, what are these? This is triplet and this is triplet. So 2 triplet mean triplet is formed due to CH2. So CH2 के दो different neighborhood हैं. On one side you got a different group CH3, on the other side you got a different group CH2. So triplet for this one, triplet for this one. Okay, and for this one is multiplet. So this one is multiplet, and then we got a singlet. So put OH up here. So this is the primary alcohol, propane 1 mole. Okay. So the next thing he is saying, we will get the next step when we oxidize the alcohol. So this alcohol would oxidize to form carboxylic acid, CH3, CH2, C double bond O, and OH. So have a look up here. This is triplet and this is quadrat, triplet and quadrat. Okay, and then this is the singlet. So neighborhood is destroyed and OH is present. So this one would oxidize to form carboxylic acid. मल्टीप्लेट भी किसकी होगी? मल्टीप्लेट इसमें है ही नहीं. ऊपर मल्टीप्लेट जो है भाई CH2 की होगी ना, इसका ट्रिपलेट, इसका भी ट्रिपलेट. Okay, and this one got the multiplet, and this one got the singlet. तो ये ऊपर बना हुआ ये. Yeah. Okay, guys. So practice will make you perfect. So I would suggest all of you do practice the questions relating to the NMR spectrometry and the mass spectrometry by yourself. Okay. So whatever the problems you got, we will discuss it inshallah.